Lesson 8.8 begins our study of systems of linear equations. A system of linear equation consists of two or more linear equations that have the same variables. A solution to that system is when the two variables are an ordered pair that is a solution of each equation or both the equations in the system. Let's see how this works. So first I'm going to graph these two equations. Y equals 2x minus 4. So I'm going to go to my y-intercept, which is at a negative 4. I'm going to use my slope to find my other point. So I'm going to go up 2 and over 1. And then I will go ahead and connect those to make it a linear equation. And let's go ahead and graph the green equation, negative 3x plus 1. So my y-intercept is at 1. Let's get that better. And using the slope, I'm going to go down 3, 1, 2, 3, and over 1. Now, as you can see, this one's a little exaggerated, but our intersecting point is at 1, negative 2. X is 1, y is negative 2. Let's see that in just a solution and not the graph. So if we want to verify that 1, negative 2 is the solution, we're going to substitute in the 1 for x and the negative 2 for y. So in the first one, we will go ahead and we will say negative 2, and we want to know, does that equal, in fact, 2 times 1 minus 4? So 2 times 1 is 2 minus 4. That does give us negative 2, so this one is correct. Let's go ahead and substitute it in for the next one. So we have negative 2 for our y. We got that from the coordinate point up there. Negative 3, and our x is going to be 1 again. And then we're adding 1 because that was in our original equation. And negative 3 times 1 will be negative 3, plus 1 will be negative 2. So that is, in fact, a solution to the system of equations. So the number of solutions, as you saw in example 1, when the linear equations have exactly one point of intersection, the related system has exactly one solution. But there are also times when we can have no solution or infinitely many solutions. We'll take a look at those. So here we have two equations again. We'll show them on the graph because that is the easiest way for us to demonstrate them. So let's go ahead and graph negative 2x plus 1. So 1 is our y-intercept, and then we're going to go down negative 2 over 1 with our slope. And we're going to go ahead and we're going to graph this equation. Let's graph the next equation. And the green one, we have our y-intercept at 5. And again, we have the same slope. And we should remember that from an earlier chapter. We have the same slope. Let's go down 2 and over 1. We are going to have, in fact, parallel lines. Same slope gives us parallel lines. We know that parallel lines will never ever intersect. So I have my lines off a little bit here. So there will be no solution. Parallel lines cannot intersect. Now we know, we could tell that even just by the written ones because they have the same slope but different y-intercepts. So that means they're going to be located slightly different on the y-axis. However, with the same slope, they will be parallel lines. All right, let's try these two equations. 2x minus y equals negative 3 and negative 4x plus 2y equals 6. Since we're demonstrating these through graphs, I need to go ahead and change this into y equals mx plus b, or slope-intercept form. So I have done that. We'll go ahead and we will go to our y-intercept, or our b, which is plus 3, or a positive 3. And then using our slope, we will go up 2 and over 1. And now you notice as we get ready to graph our next one, we have the same equation. The green would be right, I'm just going to do it slightly to the left there. Started at 3, up 2, over 1. So what happens there is we have the same equations. Because these are linear equations and we draw a line to connect the points, that means every point on that line will satisfy that and make it into a true statement. And so since they are the same line, these equations, 2x minus y equals negative 3 and negative 4x plus 2y equals 6, have exactly the same line and will have infinitely many solutions. Any solution that falls, any coordinate point that falls on this line, and the line goes on and on and on forever. All right, so our last example is going to ask us to write and solve a linear system from a word problem. We have a company that's offering 2 plans for high-speed internet service. If you take plan A, you pay $200 for the modem, but then each month will only cost you $30. If you do plan B, the modem is free, and this time you pay $40 per month for the service. So it says, after how many months are the total costs of the plans the same? And what I want you to notice in this story problem is when you're comparing, you want to get them to the same. We're going to put those two equations equaling each other. We want them to become the same. So if I go to plan A here, I rewrote that, and I'm going to write them as slope-intercept. So plan A, I want to know the total cost. It's going to be the rate, there's our per, so that's going to be our slope, 30x, and we already have to pay the $200 just to get the modem. So that's our constant term, or our y-intercept. So y equals 300x plus 200. If I go with plan B, I only have a per month, so I only have a slope of 40x. I do not have an initial cost, so I do not have more to that equation. Now I want to know when the total costs of the plans are going to be the same. So I'm going to set those two equations to equal each other. Solving, I would move my 30x, negative 30x on both sides, resulting in 200 equals 10x. Now I need to divide both sides by 10, giving me 20 equals x. And x was going to be per month, so it says after 20 months. Now to figure out how much I would be paying that is the same for both, I would substitute the 20 in for x and solve for y, giving me $800. So at 20 months, both plans would cost $800 total. Now, if I was going to graph these, I would have a pretty large graph, but I can tell you that, sorry, that was the next lesson. I can tell you that the way that you would figure out the second question, when is plan A a better deal and when is plan B a better deal, we can see that the intersecting point on plan A is 200. So the plan A is going to fall below the graph for plan B when it's at 20. So at 20, that means that plan A would cost less for more than 20 months. But up until those 20 months, plan B would be the better solution, would be a cheaper price. And that's the end of 8.8.